moment you write the formula correctly, you get 1 marks. R is D by 2. So area is pi D square by 4. So if you analyze, I have already got 3 informations per meter cube of copper. Number of electrons per meter cube. Again we recall the relation between resistance and resistivity. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, PU-Mysuru. A much awaited session. Dear students, today I will start my problem series and we will start solving the problems from the master chapter Electric Current. The last section of your question paper, 5 problems are given. You are supposed to answer 3 of them for 5 marks each. And this is one corner of the examination, especially in physics, where students take a slightly step back. But I ensure you all, if you seriously follow the sessions that we work out here, answering at least 3 problems in the examination will be very, very easy. Take out that fear. Take out that eagerness of iniquity from you all with respect to problems. Yaude problems kashta iradilla. It will be very, very easy. But remember one thing, solution to any problem can be better analyzed if you have strong conceptual depth. You need to know the concepts better. You need to understand the concepts thoroughly. If your topical depth is very, very mighty, solving the problems will be very, very easy. So, without further time lag, let us start solving the problems from the master chapter, Problems on Electric Current. The first one, as I told, question number 34 in the question paper is always from what you call the master chapter Electric Current. Please to take some time, understand the question. The solution lies on how good you have understood the data. So we will try to understand the first problem, the first numerical selected from this chapter. And remember, all these numericals are asked from the previous examinations. So from view of examinations, very important that you understand them. First one, a uniform copper wire of length 2 meters. The first data available is the length of the wire, which is 2 meters. And cross-sectional area 5 into 10 power minus 7 meter square. Length kottidare. Length is 2 meter. Cross-sectional area is given 5 into 10 power minus 7 meter square, carries a current of 2 amperes. So, if you analyze, I have already got 3 informations, what I call as data from the question. Length, which is 2 meter, cross-sectional area 5 into 10 power minus 7 meter square, and current carried is 2 ampere. Assuming that there are 8 into 10 power 28 free electrons per meter cube of copper, number of electrons per meter cube, adana electron density intlu karibodu. So there are 8 into 10 power 28 free electrons per meter cube. I have to calculate the drift velocity of electrons. So as per my assessment, using the given data, I am supposed to calculate drift velocity of the electrons. And the question is also extended. How much time, see, ಇಲ್ಲಿ time ಕೇಳಿದ್ದಾರೆ. How much time will an electron take to drift? Here, drift means to move. How much time will an electron take to drift from one end of the wire to another? Fine. We will now first make note of the data where he says length is 2 meters, length of the wire is 2 meters, cross-sectional area 5 into 10 power minus 7 meter square. And one more important thing, all units have to be expressed in SI system. If not, you have to convert the given units to SI and then calculate. So length is 2 meters, area is 5 into 10 power minus 7, current is 2 amperes. So current is 2 amperes. We are also given number of electrons per meter cube. Number, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, number ಅಂತ ಬಂದ ತಕ್ಷಣ it is represented by small n. How much it is? 8 into 10 power 28. So n is 8 into 10 power 28 electrons per meter cube. What is that? First I have to calculate. Yes, I have to first calculate the drift velocity of the electrons. Using this data, can I recall an expression, a formula, a topic from where I can calculate my drift velocity? Yes, students, very good. We know the relationship between electric current and drift velocity, where we write I is equal to NA VD into E. We have derived this expression in our session, where E is the charge of the electron. So I equals NAVD into E, from where VD is equal to I divided by NA into E. The moment you write the formula correctly, you get 1 marks. If you read the question paper thoroughly, it says problem solved without writing the formula or relevant circuit diagram or diagram will not carry marks. You have to write the formula first, then show the substitution. So on substituting here, VD equals, how much is I? 2 N 8 into 10 power 28 A 5 into 10 power minus 7 E 1.6 into 10 power minus 19. So when we solve this, we will first solve the denominator. So 8 into 5. So we have 8 into 5 into 1.6, which is 64. So this is 2 divided by 64 into, we will solve the powers now. 28 minus 7, 28 minus 7 minus 19, which is 10 to the power 2, or this is 2 divided by 64, which is 0.031. 10 to the power 2 is in the denominator. It goes to the numerator. Plus 2 is minus 2 ಆಗುತ್ತೆ. So into 10 power minus 2. So drift velocity is 0.031 into 10 power minus 2. ಯೂನಿಟ್ ಬರೆಯೋದನ್ನ ಮರಿಬೇಡಿ. ಇಷ್ಟೆಲ್ಲ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಸ್ ಮಾಡಿ ಯೂನಿಟ್ ಬರೀಲಿಲ್ಲ ಅಂದ್ರೆ 1 ಮಾರ್ಕ್ ಹಿಡಿತಾರೆ. ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಯೂನಿಟ್ ಏನು? ಇಟ್ಸ್ ಅ ಟೈಪ್ ಆಫ್ ವೆಲಾಸಿಟಿ, ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. ಸೊ ದ ಯೂನಿಟ್ is meter per second. So I have calculated the drift velocity, which is 0.031 into 10 power minus 2 meter per second. Now, in the second part of the problem, I have to calculate the time taken by the electron to move from one end of the wire to another end. What is the length of the wire? 2 meters. Andre, a 2 meters length, 2 meters distance in a travel madake, what is the time taken? Very much we know speed is nothing but distance by time. Applicating here, time equals distance traveled is nothing but the length of the wire. Alva, 2 meter length is what the electrons have to cover. So distance is L divided by speed comes to the denominator. What is the speed of the electrons here? Good. Nothing but what we have calculated as drift velocity, Vd. So this is length is 2, drift velocity is 0.031 into 10 power minus 2. So 2 divided by 0.031, which is 64.5 into 10 power minus 2, it is plus 2 agate seconds. So this is what is the speed, time taken by the electrons to drift from one end to another. Again, it is 2 divided by drift velocity 0.031, which is 64.5 into 10 power 2. So, very clearly if you see, the conceptual depth will clearly help me to solve the problem. Next one, second one, a simple problem. The resistance of a wire, resistance of a wire having a length of 0.6 meter length kottidare and diameter 0.4 millimeter is 1.5 ohm. The resistance of the wire is 1.5 ohm. Length of the wire is 0.6 meter. Diameter is 0.4 millimeter. We have to find the resistivity of its material. Now, again we note down the data. The length was 0.6 meter and the diameter was 0.4 millimeter. You'll observe Madi. Diameter is in terms of millimeters. SI unit for some length is meters. So this has to be converted into meters. So this is 0.4 into 10 power minus 3 meter milli 10 power minus 3. And the resistance is given to be 1.5 ohm. So R is 1.5 ohm, from which I have to calculate resistivity. So my dear students, again, can I recall any expression which can relate resistance and resistivity. As a consequence of Ohm's law ಓದಿದ ಮೇಲೆ ಕಾನ್ಸಿಕ್ವೆನ್ಸ್ ಆಗಿ ರೆಸಿಸ್ಟೆನ್ಸ್ ಮತ್ತೆ ರೆಸಿಸ್ಟಿವಿಟಿ ಅಂತ ಎರಡು ಕಾನ್ಸೆಪ್ಟ್ಗಳನ್ನು ಓದಿದ್ದೀವಿ. ವೇರ್ ವಿ ರೋಟ್ R is equal to rho L divided by A. See, these things you should know. You should be in a position to recall these expressions. ಅದನ್ನೇ ಕಾನ್ಸೆಪ್ಚುಯಲ್ ಡೆಪ್ತ್ ಅಂತ ಹೇಳಿದ್ದು. ಕಾನ್ಸೆಪ್ಟೇ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್ಸ್ ಕಷ್ಟ ಆಗುತ್ತೆ. ಸೊ ಆರ್ ಈಸ್ ರೋ ಎಲ್ ಡಿವೈಡೆಡ್ ಬೈ ಎ. ಆರ್ ಇದೆ, ಎಲ್ ಇದೆ, ಬಟ್ ವಾಟ್ ಈಸ್ ಎ? ವೆರಿ ಸಿಂಪಲ್. ನಾವು rho has to be calculated, which is R A by L. Now the diameter is given. How do you express area when diameter is given? Very simple. ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. When diameter is given, area is pi d square by 4. Pi r square. R is d by 2. So area is pi d square by 4. So substituting here, rho is r. So this is pi d square divided by 4L. I have just rearranged the expression. Rho beku namage. So what is rho? R into A divided by L. Manipulate ಮಾಡ್ಕೊಂಡೆ ರೋ ಸಿಕ್ಕೋ ಹಾಗೆ. ಈಗ ಡೈರೆಕ್ಟ್ ಆಗಿ ಏರಿಯಾ ಕೊಟ್ಟಿಲ್ಲ, but diameter is given. So I know area is pi d square by 4. So substituting for area, pi d square divided by 4. L ide, keep it. Now substitute. So rho is, how much is R? 1.5. We know the value of pi, 3.14. Diameter, 0.4 into 10 power minus 3 whole square d square, 4 into L, which is 0.6. Now we will simplify. So rho equals, simplification il martini, 1.5. You also take a sheet of paper when you work out. Once after you see the session, again go back, go to the questions, try to solve by yourselves, have your calculator, practice using calculators. 1.5 into 3.14 into, now 0.4 whole square ide, 0.4 into 0.4, this is 0.7536. Just for our convenience, we will check it again. 1.5 into 3.14 into 0.4 into 0.4 is 0.7536. 10 power minus 3 whole square minus 6 divided by 4 into 0.6, 2.4. Or this is 0.7536 divided by 2.4. So 0.314 into 10 power minus 6. What is the SI unit for resistivity? Recall ಮಾಡಿ ವೈವಾದಲ್ಲಿ ಕೇಳ್ತಾರೆ ಯಾವಾಗಲೂ. Good. ಓಮ್ ಮೀಟರ್. ಕೆಲವೊಂದ್ಸರಿ ಓಮ್ ಪರ್ ಮೀಟರ್ ಅಂತ ಹೇಳ್ತೀರಾ. ಇಟ್ ಇಸ್ ನಾಟ್ ಓಮ್ ಪರ್ ಮೀಟರ್, ಇಟ್ ಇಸ್ ಓಮ್ ಮೀಟರ್. Good. The third problem, quite interesting. Two wires A and B are made of the same material. Same material andre, when we say they are made of the same material, which quantity remains same? Good. Resistivity depends upon the material. So here it means resistivity remains the same. Since they are made of the same material, rho resistivity remains the same. A is twice as long as B. Nodi alli. A is twice as long as B. Length of A is 2 times the length of B. A is twice as long as B. And diameter of A is thrice that of B. He says, if the resistance of the wire is 4 ohms, which wire? A. Resistance of A is 4 ohms. I have to find the resistance of B. Now, carefully observe. Going to the solution, let L be the length and D be the diameter of which wire? B. L is the length and D is the diameter of B. L denotes the length, D denotes the diameter of which wire? B. Clearly problem ಏನು ಹೇಳುತ್ತೆ? A is twice as long as B. So what is the length of the wire A? 2L. Problem clear ಆಗಿ ಹೇಳಿದೆ. A is twice as long as B. 2L is the length of A and diameter of A is thrice that of B. So 3D is the diameter of A. Now again I have to equate resistance with resistivity as we did in our previous case. Now, for the wire A, again we recall the relation between resistance and resistivity. We told R is rho L by A. Again, area in terms of diameter. So R is rho L. Very good. Now this is pi d square by 4. ಹೇಳ್ಕೊಟ್ನಲ್ಲ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಡಯಾಮೀಟರ್ ಕೊಟ್ರೆ ಏರಿಯಾ ಇಸ್ pi d square by 4 or R is rho L. 4 goes to the numerator. divided by pi d square. Just rearrange ಮಾಡ್ಕೊಳ್ಳೋದಷ್ಟೇ. Resistance is rho L divided by A pi d square by 4. 4 numerator ಹೋಯ್ತು 4 rho L divided by pi d square. What is the resistance of the wire A? Yes, it is given to be 4. So, if we again check, resistance of A is 4. So, 4 equals 4. Rho will not change. Resistivity remains the same. Length is 2 times L divided by pi 3d whole square, or 4 equals 4 into 2 8 rho L. Numerator na simplify marde 4 into 2 8 rho L divided by 3 square is 9 pi d square. Call this equation 1. Now, for the wire B, the same equation, this one I'll consider R equals 4, rho remains the same, L is the length, pi d square, equation 2. So if you observe, I have to find R. Equation 1 divided by equation 2 I do. 4 by R equals 8 rho L divided by 9 pi d square into, I take the reciprocal of RHS of equation 2, pi d square divided by 4 rho L. Pi d square gets cancelled, rho L gets cancelled. This goes twice. So 4 by R is 2 by 9. So 36 equals 2R, or R equals 8 ohms. So this is, 18 ohms. So this is the resistance of the wire B. Next one. An unknown resistance is connected in parallel with the resistance of 4 ohms. ಇಲ್ಲಿ first circuit ಬರ್ಕೋಬೇಕಾಗತ್ತೆ. So when you write the circuit, it will help you to solve. Unknown resistance is connected in parallel with a resistance of 4 ohms. Now I say unknown resistance is R1. It is connected in parallel with a resistance of 4 ohms, which I call as R2. Similarly, other two resistances, there are 2 more resistances, 2 ohms and 3 ohms, connected in parallel. Initially, there was an unknown resistance. I didn't know the value of resistance. It was connected in parallel with the resistance of 4 ohms. Now, two other resistances, both the values I know, 2 and 3 are connected in parallel. So, again, 2 ohms and 3 ohms. I call this R3, I call this R4. Again, they are connected in parallel. So, ಎರಡು parallel combination ಇದೆ. One unknown resistance connected in parallel with 4 ohms. Another two resistances, 2 ohms and 3 ohms connected in parallel. Now, the effective resistance of these two combination is connected in series with 3.6 ohms. Now, these two combinations are connected in series with an effective resistance 3.6 ohms. RS series effective 3.6 ohms. I have to calculate what is the unknown resistance. Very simple. ಈಗ ಏನು ಅನ್ಕೊಳ್ಳೋಣ ಅಂದ್ರೆ, let R dash be the effective resistance of R1 and R2. R double dash is the effective resistance of 2 and 4 connected in parallel. I can easily calculate R dash because I know 2 and 3 are in parallel. ದಯವಿಟ್ಟು ಗಮನಿಸಿ, 2 and 3 are in parallel. I can calculate R dash, resistors in parallel. So 1 by R double dash is 1 by R3 plus 1 by R4. ನಮಗೆ ಫಾರ್ಮುಲಾ ಗೊತ್ತು. So 1 by R double dash is 1 by 2 plus 1 by 3. So 1 by 2 is half plus, don't take risk, use your calculators. We know 1 divided by 3 is 0.33. So when you add 0.833, ಗಮನಿಸಿ, ಕೆಲವರು ಇಲ್ಲಿ ತಪ್ಪು ಮಾಡ್ತೀರಾ. 0.833 is 1 by R dash, R double dash. But I want only R double dash. So R double dash is 1 divided by 0.833. ಇದನ್ನ ಮಾಡಕ್ಕೆ ಹೋಗಿರಲ್ಲ, ದಯವಿಟ್ಟು ಅದನ್ನ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ. 1 divided by 0.833 will give me 1.2 ohms. So I have calculated the effective resistance R double dash for this combination. Very simple. 1 by R3 plus 1 by R4 ಮಾಡ್ಕೊಳ್ಳೋದು. Reciprocal of this is R double dash. Now, very clearly they have told R dash and R double dash are connected in series. Very good. So RS is R dash plus R double dash. Why? They are connected in series. So from this, R dash is RS minus R double dash, 3.6 minus 1.2. So 3.6 minus 1.2, which is 2.4 ohms. Now R dash is known. Things have become simple. R dash gottide, R2 gottide. I have to calculate R1. Is very simple again. 1 by R dash is 1 by R1 plus 1 by R2. 1 by R dash is 2.4. 1 by R1 plus 1 by 4. So 1 divided by 2.4 is 0.41. 1 by R1 plus 0.25. Shift this. 0.41 minus 0.25 is 1 by R1 minus 0.25. So 0.41 minus 0.25 is 0.16 is 1 by R1. So R1 will be 1 divided by 0.16, which is nearly 6.25 ohms. So very simple, students. Nodi, circuit barkondvi. I just kept on analyzing the steps. I have arrived at the answer. Now this is a problem which is an assignment for you all. I want you all to read this, solve carefully. Two conductors of resistance 4 ohms and 8 ohms are connected in parallel with a cell of EMF 3 volt. Internal resistance 1 ohm. Calculate the current in each conductor. Go back to the sessions. Refer to the expressions. Parallel combination, current, EMF, internal resistance. Just relate them and solve the problem. In my next session, I'll work out few more problems from the previous papers which will make things easy for you all. Until then, thank you.